Hello, students. Welcome to another lesson. Today's lesson is on translating equations. And again, the standards we are focused on are the same ones we've seen throughout equations and inequalities so far. These are the equations parts. We're going to solve word problems with these things on them now. And right when I ask you to pause, you can copy down the standards that I've highlighted. You don't have to write down the full wording. We have that on the first page. And everything else you see. Go ahead and pause. Okay. The essential question here is how do we translate word problems into an equation we can solve? So really, this lesson, we're not going to solve all these problems unless the directions ask us to. We're going to just work on creating an equation from them. A lot of times students try and do these problems through guess and check. It really aggravates them when there really was a way to translate it into an equation that we can solve instead. So the first step, we have to use those skills we've learned previously about operational words and find those operational words. And I like to stay really organized. So we're going to use our our marking the text skills here, critical reading strategies, and I see that a power adapter costs 5 more than a docking station. Okay, whoa, that was some funny lines right there. It's always great when your smartboard messes with you. So we have 5 more on that docking station. So I'm going to click one page forward to help with my funny smartboard right now. So we have a power adapter. I'm going to write adapter. And it seems like, as I keep on reading, the total cost, we also have this docking station, and we don't know both. So a lot of students think this is a two variable problem, but they stated one variable in terms of another. So do we know what the docking station is? We don't. So we're going to call that the variable D. And then in that first part of the problem, they said the docking station was $5 more, or the adapter was $5 more than the docking station. So we write that as docking station plus 5. And then as we keep on reading, the total cost, that means everything added up together. Remember, the word total means to add everything up together, is $63. So how we could write this is D plus 5 plus D equals 63. And that would be an acceptable answer. If you wanted to simplify it a little bit more, 2D plus 5 equals 63 is also an acceptable answer for writing an equation. And notice the directions don't say solve. Now I started with a harder model. They're not all going to relate one variable in terms of another. That is actually a harder type problem, but you know me, I like to give you my models that are more difficult. So let's start going over our examples here. And I'm going to go to both example pages so you can copy those down. And you're going to want to pause right here. Okay, welcome back. So again, our directions just want us to create the equations for the following problems. So we're going to use that marking the text skill, that critical reading strategy. Zach has 6 shirts. So Zach, you got 6 shirts. This is, oh, I love that word is, because that means we're getting a equal sign in here. And Zach had 6 shirts, so we already kind of knew that, so I should start going from left to right so I don't get confused here. We have 4, then we have that operational word less than, twice the number, and it wants us to use n as our variable there. So we had Zach on the left here, Xavier is going to be on the right. And you may need to remember that this word than, remember, that means we have to flip the order. The thing they said first goes second, and the thing said second goes first. So the thing said second here is twice the number. Then we have the less and the 4. And that is our translation. I wanted to get a less than in there so you see that flip. Hey, on problem 2, we have Jeremy. Jeremy has 13 baseball cards. We can go ahead and start writing that down from left to right. Then you have this word is. Love that. That means equals 7 more than 1/5 the number. Okay, so remember, I like to use always skills, although the commutative property says we can add in any order. But since I saw that than, I'm going to switch the order. 1/5 m, then we have the plus, and then we have the 7. And that's now been translated, so we can solve it. On problem 3 and 4 here, these are the two common problems that get confused by students. Problem 3 is an example of when to use parentheses. We need to have 5 times the sum. That means you have to multiply the whole addition problem by the number 5. And the way that would happen is we need parentheses. Now the sum they're talking about is a number and 9. And we don't know what the number is, and it doesn't tell us what to use, so I'm going to use x. Oh, there goes my funny smartboard again. So I'm going to click myself over to the other page to fix that issue. Sorry, wrong way. Here we go. So a number is x plus 9. Then we have the is equal to, gotta like when it actually uses the word equals, is 3. Again, you may want to star this example as the distributive property being used there. You have to have 5 times the sum, and it's the way they order the words from left to right. In problem 4, it says the sum. So we're starting with the addition of 7 times a number. Doesn't tell us what to use, so I'm going to use x, and 24. So since it didn't say 7 times the sum, this does not have the distributive property being used. We had the sum show up first, so we wrote the plus sign, started writing things around the plus sign, then it says is equal to, and -8. Again, if you have any questions, remember that's what this column on the left is for. Write those questions down. Ask them in class. People will have them. Everyone learns from them. And again, we'll write our summary later on in our class. That's all today. I'll talk to you soon.